But here's where all the problems begin. As soon as our single cell embryo starts to divide, become 2 cells and 4 cells and 8 cells, etc., every single time those cells divide, the telomeres get a little bit shorter. So by the time we've gone through so much cell division that we've gotten to be as big as a newborn baby, our telomeres have already shortened down to 10,000 bases. They were at 15,000 bases when we were first conceived, and then they got as short as 10,000 bases when we were born. But the problem doesn't end there. It just gets worse because we still have a lot of growing up and a lot of cell division to go. And so the telomeres just get shorter and shorter and shorter. And when our telomeres get down to 5,000 bases, our cells lose the ability to function and we die of old age. This has been shown in the Petri dish. This has been shown by collecting skin from samples, from tissue samples from people of all different ages. And let me just go over this again. We're conceived at 15,000 bases, we're born at 10,000 bases, and we die of old age at 5,000 bases. And there's absolutely nothing we can do about this yet. And this isn't a theory. This is absolutely every single lab in the world that grows human cells in Petri dishes know that we have this clock. The limit on number of the times a human cell can divide is very limited and is definitely controlled by the length of the telomere. And I'll show some results that confirm that a little bit later. But it's the only clock, really, that's ever been discovered in humans that correlates to aging. There's been a few other clocks that people have identified, but when further study, all of them get shown to be actually affected by the length of the telomere. So this has a strong possibility of being the clock of aging. But as I said before, the only way to know it is to lengthen it. And well, first of all, let me say that it's not just aging. Scientists all over the world, there's been hundreds and hundreds of scientific peer-reviewed journal articles showing that telomere length plays a role in practically every disease you've ever heard of, including the common cold. And if I had time, I could go through all these, but it's just a tremendous correlation between telomere length and your ability to get every disease there is.